Welcome to CS 1401 Video 16.2. In Video 16.1 I discussed classes, objects, how to create objects with constructors, and how to store values in instance variables. In this video I'll talk more about working with classes and objects, and especially about defining methods. Remember the example of the class student? I defined public class student as having 6 instance variables, or fields: a string name, a string email, an int ID, an int attendance, an array of floats called quiz, and an array of floats called midterm. Now we're ready to start computing things like the average of the quizzes that a student has taken. For example, let's say that Anna Minor was present for the first 3 quizzes and got 10 points for the first quiz, 8 points for the second quiz, and 7 points for the third quiz. Let's store these values in the quiz array. If we want to know the quiz average for a student, we can write a method in the student class that computes the average of some number of quizzes. Here's the Java code. My method getQuizAverage will return a value of type float. It has one parameter, an integer called number of quizzes to compute, and that will be the number of quizzes for whose average we'll calculate. There's an accumulator called sum, and what we'll do is iterate starting from 0 through the values of the array so that we see that number of quizzes to compute. On each iteration, we'll add the value of that quiz to the accumulator, that's the variable sum, and increment the index variable I by 1. And when the loop is done, we'll return the sum divided by the number of quizzes to compute, which will be the average of the quiz scores. In the grading class, if we call this method with the parameter 3 for Anna Minor's 3 quizzes, we get back 8.33, which is exactly the right answer. We could create lots more methods to compute the average of midterms, or to compute the overall grade based on attendance, quiz average, and midterm average. By writing these methods one time for the class, we can use them repeatedly for each student object. This makes it much easier to maintain the code and to test and to debug it. Programmers usually define other methods that get and set the values of instance variables in the objects. Over the next few minutes, I'll discuss variables, access to variables, and defining methods to get and set values for variables. The variables specified by the class for its objects are called instance variables, member variables, or fields. The fields in our class student include name, email, ID, attendance, and so on. These fields are created the same way we create a variable, first by stating the type of the variable and then creating a valid variable name. Notice that these fields appear at the very beginning of the class. Although they are not part of any method, all of the methods for the class can access these variables. Some fields can store sensitive information, such as the student ID, that we may not want to share with other classes. In those cases, we can use an approach to restrict the visibility of or access to that field. We use the keyword private before the variable type. So instead of int student ID, we can write private int student ID. Similarly, if we want to allow other classes to be able to access a field, we can use the keyword public. For example, we can say public string name and public string address so that other classes have access to the values in the field's name and address. The keywords public and private are known as access modifiers. They grant different types of access to variables, methods, and classes. Let's take the object S1 as an example. We may want to update the value of some variables to store S1's information. One way to do this is to write the name of the object, which is S1, followed by a period, followed by the variable name, and then assign a value to that variable. That's how I set the email address for Anna Miner in video 16.1. s1.email equals, quote, annaminer@miners.utep.edu, close quote. It is a better practice to use in-class methods to assign a value or to read the value of a field rather than to allow other classes to manipulate the variables of an object directly. Usually, a method that assigns a value to a variable has a name starting with the word set, followed by the name of the variable. For example, in the student class, the method for assigning a value to the variable called name would be called setName. These methods that assign a value to a variable take the value as an argument. This means that these methods will always have at least one parameter. The return type is usually void because the method is used to set a value. For example, public void setName takes string student name, and the body of the method is name equals student name, where name is the instance variable for the class student. Similar to the use of set methods, we can use get methods to access the values of a field. Their names start with the verb get, followed by the variable name. For example, public string getName will return name. This method returns the value stored in the name field. Notice that the parameter list is empty and the return data type of the method is the same as the data type of the variable it is returning, in this case string. Aside from the get and set methods, we can write many other methods to do other computations. For example, the getQuizAverage method computes the average quiz grade for a given number of quizzes. Every method within a class can access all of the member variables and methods. If a method defines a variable within itself, that variable can be accessed only by the method itself. The variables declared inside a method are known as local variables. For example, let's look again at the getQuizAverage method. In this method, the variable named sum is a local variable. Methods other than getQuizAverage, even within the same class, will not be able to access sum. So that's an introduction to classes and objects, and to their implementation in Java. In the next set of videos, I'll discuss key aspects of classes and objects, including abstraction, encapsulation, inheritance, and polymorphism. See you then.